Okay, um, I'm going to go over the 7.3 practice using similar right triangles from the CK12 Geometry ebook. Number one, write the similarity statement for three triangles in the diagram. So we have a right triangle that has an altitude going down to the hypotenuse at a 90 degree. So we know that these three triangles are similar. So the first similar triangle I'm going to do is the big one. The long leg, that's the long leg, that's the short leg, and this whole thing right here is the hypotenuse. So let's say the long leg, JKL, is similar to 12 geometry to, so in the medium-sized triangle, the long leg would be this side right here. Long leg, short leg, and then this part would be the hypotenuse, JMK. Okay, so that's the medium-sized triangle. And then the last one is the smaller triangle here. The long leg of the smaller triangle is this length. That would be the long leg for the shorter. This would be the short leg, and this would be the hypotenuse. Long leg to the short leg. So long leg would be K to ML. K, M, L. Okay, so what does this mean? This means that these points correspond. J corresponds of the large triangle corresponds to J of the medium, which corresponds to K of the small. JK corresponds to JM, corresponds to KM, etc. The geometric mean is a quantity in that it is to the smaller as the larger is to that quantity. It works with two positive numbers, A and B, such that A over X equals X over B. Cross multiply and get X squared equals A times B. Or X equals square root of A times B. So let's apply this to two positive numbers, 16 and 32. We're going to find the geometric mean, and then we're going to simplify all radicals. This might be the most difficult part, is simplifying. The equation's easy, the simplifying requires some practice. Okay, so we've got A over X equals X over B. And here are two numbers, so I write 16 over X equals X over 32. Now I'm going to cross multiply, so I get X times X is X squared, and 16 times 32. I could multiply this out, but I want to simplify the radical. When I take the square root of both sides, I want to try to figure out what perfect squares I can pull out of this. So I don't really want to multiply this yet, but I do see a couple of things. One, I see 16 is already a perfect square, and I see 32 has some factors that might work as a perfect square. So what are the factors of 32 that are perfect square? Well, 4 is a factor of 32. That's 4 times 8. And then 8 also has another perfect square factor of 4, and then I'm left with a 2. But I also see that 16 is a factor. 16 times 2 is 32, and 16 is a perfect square. So how about I rewrite this as 16, that's the same one right there, and then 32 is 16 times 2. Now, I could rewrite this again, separating the radicals. Square root of 16 is 4, square root of this 16 is 4, and the root 2 I can't simplify, can't take the square root of 2, and 4 times 4 is 16, so 16 Root 2 is my answer. Okay. Next one, 10 and 14. Okay, so I've got a over x equals x over b. 10 over x equals x over 14. Cross multiply, x times x is x squared. 10 times 14. Okay, so there are no factors of 10 that are perfect square. There are no factors of 14 that are perfect square. However, I'll take the square root of both sides on this. The factors of 10 are 2 and 5, and the factors of 14 are 2 and 7. So I've got two pairs here that are matching up, the 2's. That 2 times 2 would be 4, and the square root of 4 is 2. So I can take that out. So the square root of 4, that would be 2, and the 5 and 7 don't simplify. Can't take the square root of those. So let's just put that back together. 5 times 7 is 35. Root 35. Okay, there's that. Last one here of this kind. So a over x equals x over b. So cross multiply, substitute here, I get 40 over x equals x over 100. Cross multiply. 100 times 40. Now I got to take the square root of both sides here. So we should see that 100 is a perfect square here. So we've got the 100. 40 factors into 4 times 10, and 10 factors into 2 and 5. Well, we don't have any perfect square factors there, but 4 is. So what can I take out here? Square root of 100 is 10. The square root of 4 is 2. Root 10 stays under the radical. 10 times 2 is 20. 20 root 10. And that's my final answer, simplified. Okay, so now how do we apply this with our similar triangles? Find the lengths of the missing variables, simplify all radicals. Okay, so I have 3 similar triangles in here, just that we saw in number 1. I've got this larger triangle, this medium-sized triangle inside the large triangle, and I have a small triangle also inside. So we're going to use the geometric mean here, but first let's take a look at the corresponding sides here. So this is the long side, the long leg of the large triangle, and this would be the short leg of the large triangle. So I could say long leg divided by short leg is going to be equal to, now this might be the short leg of the medium-sized triangle right here, but it happens to be the longer side of the smaller triangle. So this is the long leg for the short triangle, or the small one, and this ends up being the small leg of the little triangle. So we could say long leg to short leg. So this is the medium-sized triangle. This is the small triangle. Okay? So that's going to be 30 to x, 30 to x, equals x to 24. Notice this is in the same equation that we just used for the geometric mean. A to x equals x to b. So this altitude ends up being the geometric mean of these two parts of the hypotenuse of the larger triangle. All right, so now let's solve this. Cross multiply. Now, let's break this up. Let's see. 30 is 5 and 6. 24 is 4 and 6. I see two pairs here. Let's take the square root of both sides. So I'm dealing with this. So 6 and 6 are going to make 36. So if I take the square root of 36, that would be 6. 6 pops out. What's left? 5 and 4. 5 and 4 are... 4 is also a perfect square right here. 4, I can take the square root of 4, and that would be 2. So 2 comes out. And then 5 I'm left with on the inside. So 2 times 6 is 12, root 5. And that's my answer. Okay, next problem, 13. All right, so we're looking for z here. I know the hypotenuse is 18, and I know that this distance right here is 9. So this must be 9 too, right? Okay, so I'm finding a little bit more information now. I know that this is a right angle, and I know that both of these parts are congruent. Well, that must mean that this is also congruent, because we have an isosceles triangle here. Oh, let's back up here. That's not congruent. I know that if these two are congruent, then I know that these sides right here are going to be congruent. So therefore, if this is a 90, this has to be 45. These angles have to be 45. And that means that this is 45. This is being bisected. So then I know, then I could say that these three segments are congruent. So I have two isosceles right triangles. Okay, so that means this is 9. 9, 9. How can I use those to solve for z? I'll take a look at this triangle right here. What can I use to solve for z? Pythagorean theorem. So my legs are 9 and 9, and my hypotenuse is z. 9 squared plus 9 squared equals z squared. 81 plus 81. Add those together. So 80 and 80 are 160, and then I've got two ones left over, so that'll be 162. And I need to take the square root of that. So 81 plus 81 is 162. That must mean that 81 times 2 is also 162, right? What do we know about 81? It's a perfect square. So this simplifies to 9 root 2. This ends up being a special triangle, and we'll learn about those ratios later. Okay, so that's our answer for 13. Okay, number 15. There's two ways to do this. I think I'll solve this by first finding this altitude, and why don't I call that x? So if I find x, which ends up being the geometric mean of 15 and 16, then I could use the Pythagorean theorem to find y. So the geometric mean is a over x equals x over b, and 15 I can substitute for a and 16 for b. So now I can cross multiply. I'm not going to multiply these numbers together because I want to factor the perfect squares, which 16 is. 15 would be 3 and 5. No perfect squares there, so this would be 4 root 15. And that's x. So this is 4 root 15, the altitude. So now I can use that to find the hypotenuse of this orange triangle here. A leg of 15 and another leg of 4 root 15. So I can use the Pythagorean theorem. So I get 15 squared plus 4 root 15 squared equals y squared. 15 squared is 225. 4 root 15 squared would be 4 squared, which is 16, times root 15 squared, which would just be 15, because the radical and the exponent would cancel each other. 16 times 15 is 240. Add those together, I get 465. Then I need to take the square root of that. So y equals the square root of 465, which doesn't simplify any further. The other way I could solve this is saying 15 to y, which is the short side to the hypotenuse, equals y to 15 plus 16, which would be the short side to the hypotenuse of the large triangle. Y to 15 plus 16 is 31. Now if I cross multiply here, I end up getting y squared equals 465. I take the square root of both sides. I get the same answer as I did before. So this is one step. This is basically two steps. Let's take a look at 17. In 17 I changed just a little bit from the practice. I've removed these variables just to simplify the problem a little bit. So we have 10 as this leg, 8 as this leg, which is the altitude of the large triangle, and x, the unknown piece. We can use the geometric mean again here. I can say 10 to 8 equals 8 to x. 10 to 8 equals 8 to x. Before we had this as the unknown, and we knew this side right here. So now when we look, we only see one x. We don't have two x's, so we're not going to get a square root in this one. Cross multiply. So I get 10x equals 64. Divide both sides by 10. And I could take a 2 out, 32 fifths. Okay. last one, 19. All right, we have three variables here we're looking for. Well, I've got the altitude is 9, and I've got the large leg of the big triangle is 41. Well, I can't find y or z yet because the small triangle I don't have enough information. But the medium-sized triangle here, I do. I could find z. So let's get z first by using Pythagorean theorem. A squared plus b squared equals c squared. Z squared plus 9 squared, those are my two legs, equals 41 squared. Remember, 41 is across from the right angle this side, so that's the hypotenuse. Z squared plus 81 equals 41 squared. So 41 squared is 1,681. 1,681. So now I need to subtract 81 to both sides. Oh, that looks nice. Just gives me 1,600. Now I need to take the square root of both sides. Now 1,600 is a perfect square. Now if you can't see it, we can see this. 16 times 100 is 1,600. And 16 is a perfect square is 4, and 10 is a perfect 100 is a perfect square is 10. 4 times 10 is 40. So 40 times 40 would give you 1,600. Okay, so there's z. Z is 40. So let's label it here. 40. So now I still can't get x over here, but I can find y. I can use the geometric mean here. I've got this side and this side and this side to make up the geometric mean. I've got a to x equals x to b. So I can say 40 to 9 equals 9 to y. 9 in this case is the geometric mean. That's why the 9's are here. Cross multiply. 40x equals 81. Divide both sides by 40. And this is not going to really simplify nicely, is it? Nothing goes into, I can't simplify this fraction. So it's going to make x a little interesting here. So I've got y, 81 over 40. Now I need to find x. Pythagorean theorem. A squared plus b squared equals c squared. So my legs are 81 over 40 and 9. X is my hypotenuse. Okay, well, 9 squared is 81. And 40 squared on the bottom I have to do. It's going to be 1,600. And 81 squared is 6561. It's a little ugly here. So to add these together, I need a common denominator, which looks like it's going to have to be 1,600. So I'm going to have to multiply top and bottom here by 1,600. Oof. So 6561 over 1,600 plus 81 times 1,600. add that to the numerator. 65, 61. Wow. Okay. Now I need to take the square root of both sides. Well, the square root of 1600 is 40 again. And let's just see if this thing's a perfect square. And it is. Oh my goodness, this number right here is a perfect square. 369. And I wonder, let's see, if we can simplify this any further. 369. I don't think so. I think that's our final answer. Well, it's not nearly as ugly as I thought it could be. Okay, 36 divided by 40. 369 divided by 40. That's approximately 9.225. See if that makes sense. Yeah. So this value right here is equal to 9.225, which makes sense. It's a little bit bigger than the leg 9 right here. Okay, that's it. I hope that makes sense, and I hope it's helpful.